Welcome! Today, we're diving deep into the architecture of Inventory X, which is a professional-grade inventory system for Unreal Engine. We're going to look at how it's designed from the ground up to be tough, fast, and totally ready for the most demanding multiplayer games out there.
All right, so here's the game plan. We'll kick things off by talking about the problem pretty much every developer runs into. Then, we'll get into the core idea that drives this whole system's design. After that, it's a deep dive into the architecture, how it nails multiplayer and frees up the UI, and finally, we'll see how it scales for some truly massive games. So, let's start with something every game developer knows and, let's be honest, kind of dreads: building the inventory.
On the surface, it seems so simple, right? It's just a grid you put stuff in. But let's ask the big question that hits every developer at some point. Why does this thing that looks so easy on paper so often turn into a complete nightmare to actually build and maintain?
And here's why it becomes a nightmare. You're trying to juggle all of these different things at once. You need rock-solid multiplayer where the server is always in charge. You've got to handle crazy layouts, like grids where items can rotate, or even putting bags inside of other bags. And all of that has to run super smoothly, without eating up memory or choking your network. But the classic mistake? Tying your UI code directly into your game logic. That makes your whole system fragile, full of bugs, and basically impossible to add new features to later on. So Inventory X tackles these challenges head-on, and it does it by starting with a core design philosophy. This isn't just about writing code. It's about a fundamental way of thinking that stops those common problems before they can even start. And it all boils down to this one simple, powerful idea: backend first and UI agnostic. What does that mean? It means the system's core brain, the runtime, is completely separate from what the player sees. It has no idea what a widget is, what drag and drop looks like, or what buttons the player is pressing. It only cares about the raw data, the rules, and the state of the inventory. Period. And this slide right here shows that separation perfectly. You've got two completely different modules. The core Inventory X module is pure C++, handling all the heavy lifting, the game logic, the networking. Then you have a totally separate UI module, Inventory X Sample, which is just one of many possible ways to use that backend. The backend doesn't need the UI, but the UI absolutely needs the backend. It is a one-way street, and that is absolutely the key. Okay, so with that philosophy locked in, let's peel back the layers and look at the actual architecture. This is where we get into the real nuts and bolts of how this thing is actually put together. You can really boil the whole system down into 4 fundamental layers, each one building on the last. You start with definitions. These are just reusable assets that describe what an item is. Then you have the live state and rules, which are represented by super lightweight data structures. On top of that, you have an operations engine that makes sure every single action is validated properly. And finally, the networking layer wraps it all up to handle all the tricky stuff for multiplayer. Now, speaking of that foundation, this brings up a really critical point about the whole design. Performance isn't just a feature. It's not an afterthought. It's baked into the system from the absolute ground floor. And it gets that performance in a few really clever ways. Instead of using Unreal's standard and kind of heavy U-objects for every item, it uses lightweight C++ structs. Think of them as just simple buckets for data. This cuts down memory usage like you wouldn't believe. It also uses stable handles to refer to items instead of direct pointers, so references never break. And for networking, it's genius. It only sends a tiny stable ID for an item's definition across the network, saving a massive amount of bandwidth. And because that foundation is so solid and fast, it's also incredibly flexible. This same core system can power all sorts of inventory types you see in games today, from simple linear slots to complex grids with rotating items, special equipment slots, and yeah, even containers inside other containers, like a backpack. All right, so we've got a flexible, performant system. Now let's talk about the ultimate stress test: multiplayer. This is where so many homemade inventory systems just completely fall apart. And when it comes to multiplayer, there is one golden rule. A non-negotiable law: the server is king. The server always has the final say on what's in every inventory. The player's client can never be fully trusted. It's just showing a copy of what the server says is true. Okay, but wait a minute. If you have to wait for the server to approve every little thing, won't the game feel laggy and unresponsive? Well, that's where the magic of client-side prediction comes in. When you move an item, your client instantly pretends it worked. It feels immediate, but in the background, it's asking the server for permission. The server then sends back the real answer, and your client either confirms its prediction or quickly corrects itself. And making all this happen is a really sophisticated networking layer. It's strictly server authoritative, no exceptions. It uses Unreal's fast array system to only replicate the data that has actually changed, which is super efficient. And it has a formal 7-step process for sorting out any differences between what the client predicted and what the server says is true. So we've built this incredibly powerful networked backend. That's great, but what does it actually mean for you, the developer, who has to make the thing look good? What's the big payoff? Well, the payoff is huge, and it's simple: total creative freedom. The user interface is just a consumer of the backend's information. The core system doesn't depend on it at all. That means you can build whatever kind of interface you can dream up using any tech you want. And this diagram really drives that point home. It's a strict one-way dependency. The sample UI module needs the core module to function, sure, but the core has zero knowledge of the UI. It doesn't care if you're using Unreal's UMG or Slate or some crazy new UI framework. You could rip out the entire sample UI and build your own from scratch, and the backend wouldn't even notice.
And the cool thing is, the architecture is designed to think bigger than just one player's backpack. It's built from the start to handle even more complex game systems down the road. And that bigger picture thinking is formalized in something called Layer 2. You can think of this as an optional expansion pack for your inventory, designed specifically for those big, complex features where two different inventories need to talk to each other.
I mean, think about it. Looting a chest, trading with another player, using a guild bank. That's not just one inventory anymore, it's two. Layer 2 gives you the system for that. It has a secure, server-controlled session system to make sure two people can't grab the same item at once. It supports atomic operations like transferring items, and, get this, it extends client-side prediction to these interactions too, so even looting feels instant. So when you put it all together, what you really have is a foundation that can truly scale. It's built to handle the simple stuff like one player's inventory really elegantly and with great performance, but it's also fully ready to power the massive, interconnected, enterprise-level systems that modern online games demand. So, when the inventory is no longer the nightmare part of your project, when the backend is this solid, and when multiplayer just works, the only real question left to ask is, what are you going to build with it?